Before I kick off with the panel session today, I would like to start by respectfully acknowledging the traditional owners and custodians of the varied, given we're in many locations and beautiful lands across the country on which we meet today, and pay my respects to elders past, present and emerging. So no secret, it's often a struggle for Australian industry to stay competitive, and the high cost of energy is a challenge that faces a lot of them. Outside of this, Australia's made the commitment to get to net zero by 2050, and there's a bunch of targets around the place sitting underneath this. So we can't achieve any of this without industry. So this is sort of where electrification of industrial heat processes enters the chat, because it can help to reduce costs for industry whilst also reducing emissions. Both of these are important for industry and for the community as a whole. So today our panel is centering around two questions, which are what can end users actually do to electrify their industrial heat processes now? And what can governments do to enable them to do more into the future? We've got an excellent panel and I won't harp on about it, but they are on the slide anyway. We've got Jarrod from the Australian Alliance for Energy Productivity, or A2EP. We've got Silvia from Schneider Electric, and we've got Tennant from the Australian Industry Group, or AI Group. So we will be doing a Q&A at the end. So if you do have questions throughout, please put those in the Q&A function of the Zoom, not the chat function. If you accidentally put it in the chat function, please copy it over to the Q&A. It will just make life easier for everyone and ensure that we can see your question. So with that, I will kick off with our first question that I'd like to pose to our panel today. And it's a simple one, but a big one. What options for industrial heat electrification are available to industry, and particularly Australian industry?
I was holding back for Silvia, but I'll jump in then.
If you want, I can also go.
Please, Silvia.
Okay. So, well, first of all, good morning for all the people that are joining, also not from Australia, or good afternoon, everyone. So, yes, I think that when we think about industry electrification, first thing is that we have electric technologies that can cover the whole temperature spectrum that is needed for industrial processes. So from low temperature to high temperature. But when we want to strategize industry electrification, we probably want to think first of what are the low-hanging fruits. And I think for this, we have to think about three elements. One is which technologies can be implemented across multiple industrial sectors. So not only one, but multiple. And so these technologies, for example, are those that cover steam production, drying, or hot water production. And they can be transversal. The second element is which technologies we have today that are mature and can be implemented if needed, right? So which are commercially available for industry. And the third element is we prefer to save energy, so the more efficient, the better. And I think for this, in this sense, the heat pumps cover all these three elements, right? They can be implemented pretty transversally, and that's what we are seeing. For example, also Schneider Electric clients, we have clients coming from multiple sectors, pharmaceutical, food and beverages, ceramic, multiple industrial sectors all want to have studies performed on electrification, and heat pumps is always the technology, a bit the starting point, right? And but obviously there are not only heat pumps, there are also electric boilers, mechanical vapor recompressors, which are a type of heat pump, and electrical dryers. So these, in my opinion, are the low-hanging fruit. And I want to close saying one thing, that why we think that transversal technologies are better. Because industry relies on experience, right? It's very difficult for industry to transition from what they know to something that they do not know. So the more experience we gain, the more practical experience, pilots, demonstration, but actual production with these technologies, the better. The more trust we build, or the most trust industry builds on these technologies. So it's very important that we start from this, because we see that industry really picks up in a sort of a cascade manner technologies where they know that they can rely upon.
And Not much to build on that one. I think Silvia's covered really the whole lot. That the only thing I'll add is that there's a few other minor technologies and niche technologies happening with pulsed electric field and infrared and microwave. But these are very much sort of niche applications, and they don't have this heat pump coefficient of performance benefit that's really required right now at the current electricity to gas price ratio. When you get that coefficient of performance or have efficiency of 300%, that's really what you need at the moment with the current price settings, if you're just looking at pure economical transition. And so that's why the heat pump wins out. But over time, electricity price trends, gas price trends, you'll see these other ones certainly coming in more into the equation, and higher costs for carbon, higher sales value for green products. Then there's some other levers that will start seeing those other options like electrode boilers and what have you starting to come more into play from what we're seeing.
And I just add that I hear about exciting, new in some ways, very simple in other ways, developments in thermal energy storage that could wind up being very important to enabling both the electrification of parts of heavy industry and also the easier integration of renewable energy, both for those facilities and the wider system. But I don't think there's a heap of actual installation of those things happening here yet, and we'll learn a lot from the early installations that are taking place overseas. Maybe some of that activity will take place here, supported through ARENA and other public funding, but that's more of a watch this space rather than you're going to be ready to get something off the shelf now situation, as far as I'm aware anyway.
And a strong theme coming through here around the value of mature sort of shovel-ready stuff that we could be implementing. And with that, actually, a question has come through from Tom for Silvia, asking with regard to heat pumps for process heat, what size range are you typically working with? So if we could give everyone an idea on that side of things.
Yes, well, the heat capacity of heat pumps, industrial heat pumps, really depends on the temperature output of the heat pump, or it's strictly correlated to it. So we do have heat pumps that cover up to 10 megawatt heat capacity. And obviously, industrial processes also need higher heat capacity. So the higher, the better. But for the moment, we do have heat pumps that can get to 10 megawatts and maybe even higher. I'm not sure, but definitely for sure, we do have heat pumps operating in the for industry operating in the range between 0.1 and 10 megawatts heat capacity.
Indeed, on the drawing board, there's certainly designs. I think it's MAN Turbo and Siemens talking 50, 100, 150 megawatts there as well. But certainly the most common we're seeing through which is viable today is usually in the beverage industry, and that's usually requiring 1 or 2 megawatts, which is readily available for a lot of different types.
And I have another question here from the sort of ominously named anonymous attendee. Anonymous, asking about geothermal. So is there a comparison between air-to-air heat pump to geothermal heat pump? What scenarios would geothermal make financial sense?
I would suggest this is all about geothermal, completely related to how far down you go, to what temperature you have. And certainly in parts of the country, in Perth and in Victoria, Gippsland particularly, you don't have to go very far to get some high quality 60 degree or so water, in which case that's going to look very good. It also can be really well used in the southern states, where you've got regularly find yourself in that position of between sort of 0 and 6 degrees ambient, where you start freezing up the coils which are getting rid of the cold, and start having to go into defrost cycles, and the impact on the performance there. So that sort of southern type areas for using geothermal, I think absolutely it's going to be quite viable where the space is available, where the driller rigs are available, blah blah blah. It's certainly not one to discount, that's for sure.
Fantastic. And thanks to Tom and Anonymous for asking the questions. We might move on to the next one, but for those of you online, feel free to continue to add questions into the Q&A function in the event you think of something as we continue on, even if it relates to this one. We'll circle back to questioning at the end. So with that, we've heard a bit about the things that are available, the low-hanging fruit. So let's get into the why. So why would a business, why would industry move away from what they have been doing and replace their equipment or retrofit their facilities to include these types of sort of electrified heat processes? Tennant?
Yeah.
I figured it'd be you.
So there's three main drivers that are both systemically and individually important, and they are price, reliability, and emissions. So on the price front, the days of what we used to think of as cheap gas are long behind us, and we are in a situation where the federal government's ambition is to restrict the wholesale price of gas to $12 a gigajoule. Now, a decade ago, it was $4 a gigajoule. So that's, I don't know if you call that a raising of ambition or a lowering of ambition, but the price outlook for gas is not great. Now, of course, it's not always going to be as bad as it was for a period last year when we had gas being priced locally at $40, $50 a gigajoule. And there is some prospect of global gas markets being oversupplied with gas later this year. But, and I've seen somebody's just lost sound for me. No, nobody else is affected. All right. So there are prospects of global gas oversupply later this decade because of the combination of a lot of demand evaporating with policy and price responses to what has happened in the aftermath of the war in Ukraine, and the additional supplies that are coming through from some investors in North America and the Middle East who've had a rush of blood to the head. But on average, I would expect prices to be not good for gas relative to any historical experience in Australia. On the supply adequacy front, we have a strong rapid decrease in the gas production from offshore Victoria, which used to be the bulk of the gas that was produced in the east. The geology, like you can just about hear the sucking sounds as the last gas is starting to be accessed there. And everything else is coming from the north, from Queensland, and maybe down the track from the Northern Territory. There are significant worries that the gas market is going to be short of supply every winter from 2027-28. There's a lot of effort going on to address that. Demand side can help to address that, not being vulnerable to swings in the availability of gas is a helpful thing. And then on the emissions front, while depending on how you do the numbers, gas is less emitting, certainly for combustion, much less emitting than burning coal, it's still pretty emitting. And the depths of emissions targets that all levels of government are now adopting are hard. It's hard to see how those will be met without very deep contractions in gas emissions. Individual company targets, which are increasingly set, will also require that. So, for example, but it's an important example, Victoria committed earlier this year to achieve a 75 to 80% emissions reduction versus 2005 levels by 2035. That's 12 years from now. And a very crude model, and they're all pretty crude in the end, would suggest that that kind of number turns into the gas network, like the distribution part of it, retires sometime between 2035 and 2040 in Victoria. There's a lot of effort involved in achieving that, but an enormous amount of change, electrification and other solutions are going to be needed for the economy as a whole. And it's very much going to be in the interests of individual energy users to get cracking on their options so that they have a pathway that works for them, rather than being caught up in the death spiral of the gas system, which is a very possible outcome.
That was a happy point, Tennant. Avoid the death spiral is a fairly strong message, I think, for everybody online. Silvia or Jarrod, do you have anything you would like to add to that?
Yes, maybe the point of another important point of why we maybe want to distance from the relationship with gas of industry is changing, is that well, we need. The important thing, what this war has showed in Europe, for example, and not only Europe, these are consequences all over the world, is the fact of securing energy. So industry needs secure energy at prices that they can rely upon. And for example, what we see a lot from companies these days, also among our clients, is strategizing the energy supply for the next 10, 15 years. And how this can be done, it's by buying PPAs and then electrifying your process. In this way, you secure energy procurement at a fixed price, clean energy, and at the same time, you make sure that your process changes according to the energy supply that you are securing and saving energy, because most of the time electrification leads to saving energy. And the other thing is that right now our governments put very ambitious climate targets, right? And we are moving towards a decarbonized economy and society. It's clear, the path is clear. Then with the speed, if we will meet these targets, it's another topic, but we are moving there. And all the innovation, all the fun is coming from there, right? New business models, think about energy as a service. New ways of securing energy, think about PPAs, for example. New technologies. There is an ocean of unexplored potential there. New ways of using energy. Think about the concept of smart, flexible, even using heat pumps to regulate off-peak load hours. So even political innovation is there, right? New policy frameworks. So I don't see an opportunity for industry to stay behind when everyone else is moving towards that direction. So the opportunities are there. We tend to see only the challenges, but I do see huge opportunities if you want to tap into them, and really even business opportunities. So, yeah.
Absolutely. I just want one more point on the opportunity, and that's that the sales opportunity, the revenue opportunity of selling green products. We're a little bit immature in the market here in Australia. But how far can it be away before government contracts start saying yes, more will be paid for green cement, green building materials? How far are we away before our major grocery retailers are forcing or giving preference to food producers who have decarbonised, and that requires getting off gas?
Yeah, absolutely. Definitely a lot of businesses looking to clean up their supply chains to meet their own sort of sustainability mandates and support these wider societal targets. Definitely a strong theme coming through there around future-proofing for business and not falling into a death spiral off a cliff when it comes crunch time. There's been a few sort of interesting questions coming through. Some might be more relevant to chat about later on, although there is one in here for panelists regarding someone trying to wrangle a PPA for a manufacturing site in New South Wales. You can type an answer, panelists, so if anyone has any intel on that, you may want to have a look at Jasmine's question and type something on the side. But moving on to sort of the next point that we have is, okay, so we've heard that there are a lot of options that businesses could be taking. There's a lot of low-hanging fruit. We've heard of a pretty clear set of reasons why it makes good sense for industry to make this transition, to look at replacing their equipment and electrifying. So why hasn't there been as much uptake of this in Australia as we would like? Why do we think that is?
Well, we touched on a little bit before, and that's that electricity to gas price ratio. Historically, most of our manufacturers have seen costs for gas, I'm going to say around about $10 per gigajoule. Meanwhile, their electricity has been effectively around about $30 or $40 a gigajoule, but that's really changing now. So that's coming much closer. But it's that ratio which does drive a lot of decision making and for how economical the transition is. So that is moving, and I think we'll see some more momentum there. The products are there. The supply chains are there. The ones that can install the equipment and maintain it, that is there. There is also a little bit of an issue we have with the overall design concept and getting away from a like for like replacement thinking to make it more economical. But that'll come with training and experience, and as we get more installations and have learnings from those, people will learn how to install these more economically, and you'll start seeing that learning curve and that improvement happening there. And I think that's going to provide at least another 20-30% improvement over the next 3 years if we can get enough installations going and enough knowledge sharing happening as well.
I'd offer one more thought, which is that I think that in energy user land, we've been going through a lot of stages of grieving for the price and viability of industrial gas use. Like, gas is very useful, and businesses have made a lot of use of it to do a bunch of things that are handy for them and customers want. And for a long time, I think people hoped and were encouraged to hope, maybe more than was justifiable, that things were going to turn around price-wise, and we were going to get back to something approaching a price that was viable. And I think it's very hard to sustain that hope. The federal government are doing their best, but again, the limit of their ambition is prices that are around triple the long-term historic average. So I think like we're moving through denial, anger, bargaining, we're getting to acceptance, and then like, what are we going to do next? Yeah.
There's a few questions coming through, and some of them are definitely going to be answered in my plan for the next question. However, there has been one come through from Michael, just sort of asking, I guess, sort of flipping back to some of the technologies we've been talking about on, can the panel elaborate on how heat pumps can provide flexibility? Michael's understanding was that the heat pump cycles suffer significant efficiency losses with variable compression power input. So does anyone want to quickly jump in and answer that?
Yeah, the way we discuss, we conceive flexibility, it's about, so we know that there is this problem of peak load hours, off-peak load hours, right? So the way a heat pump can help that is to function or be plugged to when there are off-peak load hours, so when electricity is cheaper. Obviously, this, and then obviously supported by storage, for example. So the point is, I think the important concept here is that the more we rely on renewable electricity, the more flexibility and smart use of electricity we need. This is, I think, a logic thought if you think about what it means to electrify all our end-use sectors, right? So it's a huge amount of electricity. Today, we do not produce all that electricity. So it's clear that we cannot continue to use energy the way we do. So we need smart approaches, and heat pumps help with that. First of all, in general, heat pumps are a technology that is smart per se because they produce cooling and heating at the same time. So in this sense, plugging a heat pump when the peak off-peak load hours, when electricity tariffs are lower, can help save energy on top of the efficiency gains that a heat pump gives, but can help saving costs on the energy. And in the end, obviously, the heat storage will be needed for electrification, right? We need to have this cycle where we can store heat when we produce heat and electricity is cheap, and then reuse it when we cannot take the electricity because electricity is too expensive. And this approach to using energy, we have to make peace with it in a way, right? Because we need to really save this if we go for electrification of all the end-use sectors.
And if there was a question there specifically about compressor type operation, heat pump operation, if you went back in pre-VSD years, yes, part load efficiency and the decrease in efficiency was substantial. But essentially, all major heat pump installations now are going to be VSD controlled, and that part load efficiency loss is going to be minimal. If not, you'll build it up with smaller units, maybe a three units to perform your requirements, and therefore you can run each one at the optimal level. So part load efficiency, not seeing that come in as a major issue in any sort of modelling and sizing things that I've seen lately.
Fantastic. Thank you for that. Well, we might move on to my next question, which does in part answer a few of the questions that are coming in through the Q&A, which is what policy, regulatory and other settings could be drivers of increased uptake and help industry to get going with this. And a few of the sort of themes coming through in the questions would be sort of Bradley's asking, well, does the government need to get involved? Would targeted grants help? But then we've got an anonymous attendee saying, well, how do we create a culture of electrification and not just rely on businesses being pushed by rebates or waiting for handouts? We've also got Andrew asking, well, what's the role of energy efficiency schemes? We've also got Tristan pointing out that, maybe there's a role for instant depreciation. What OPEX saving based finance options are there? So obviously everyone's kind of thinking about the solutions now, listening to this. So it would be really interesting to get your perspectives on those sort of policy, regulatory and other settings that could help to move this along. Tennant, I know you're excited to answer this question. So take it away.
Well, I'll highlight one of the overarching ideas that was in a recent report from the Grattan Institute on policy around getting off gas. Now, that report was very household focused, but it had some ideas that were much more broadly relevant as well. And in particular, the idea of a phasing of policy from handouts to phase outs. That is setting up incentives of an appropriate sort for the particular kinds of energy use contexts that they're aimed at, because there are very different issues between different sorts of energy user. Do they own the building they're in? Are they sharing services with multiple other users? Many factors are relevant, but incentives have a place. Incentives can't do everything, both because on their own are sort of a do what you want. Here's a little assistance if you want to do this kind of thing, may not actually produce the rate of change or coordination that's needed, and may not be financially sustainable for government. But also the benefit of policy measures with a harder edge, whether they are standards for products or appliances or kinds of equipment, or obligation schemes, building regulations. The benefit is, among other things, that they sharpen the incentive to make use of the financial incentives while they're available, so that you will be ready as and when regulatory measures phase up. I think governments that tried to regulate electrification starting tomorrow would have a very big negative reaction from all kinds of energy users and everybody else. But setting out a timeline over which financial assistance will give way to regulatory expectations is a reasonable way to balance the flexibility that's needed, but also the urgency of transition.
I'll build on that urgency of transition there and say, are grants needed? Yes. No two ways about it. There is such a first mover disadvantage where if you're the first one in an industry to install, let's say, industrial heat pump, there's at least a 50% first mover disadvantage there, and that's worn by the end user, the supplier, the contractor, the installer, the equipment manufacturer. Everyone's got to somehow wear that, and to make that fair, there needs to be some help there. If we could wait another 20 years and wait for these normal cycles of learning through industry to happen, then no worries. Don't kick it off with grants programs, which comes with knowledge sharing, because it would happen. But typically, by the time someone goes ahead with a project, designs it, goes ahead, installs it, and has the lessons learned, you're about a 2 or 3 year cycle there. So if you kept that up and that just a sequential learning curve there, we're about 10 years away before being able to do this really well. A grants incentives program using here and now technology would see decarbonisation happen so much quicker. So I'll say yes, grants are needed for a good few years while we get that learning happening and we get rid of that first mover disadvantage. And then you'll see costs really starting to flip over at the same time with market pressures and market advantage of being decarbonised products. So if we want to get things moving, yes, for sure.
May I add to this point of what can we do to let's say, implement more electrification in industry? Something that is, in my opinion, complementary to policies, because we need policy support, right? This is a big transition we are talking about. But there is also the opportunity of developing new business models. In particular, I am a fan of energy as a service, and I see that this is spreading very quickly. And what energy as a service does is that he relieves the client or whoever wants to install the technology from those capital costs, right? So, and I say this because when industry is uncertain on a new technology, then they also are reluctant to invest in that, right? But if they believe this could be an option and they are lightened by that upfront capital cost, then this helps them. This is the little push that they need to invest in that. And so energy as a service, what they do is the client would get, for example, I present the model that we have in Schneider Electric, but there are multiple models. You will read a lot. This is also now being presented in the latest IRENA report on innovation for electrification, right? But the model we use in Schneider Electric, for example, is the client will not pay the capital cost. There is an investor who does that. So the client gets the technology installed, it's released from the operation and maintenance cost. And what the client pays is a so-called megawatt hour, which is the energy savings. So you have a benchmark of energy that they would use, for example, before installing a heat pump, and the energy savings estimated by us of what they will save in terms every month of energy. And that's, this contract is established by that, and then the client pays those megawatt hours. And in this sense, the client will pay for a contract, let's say 10, 15 years, and it's released by that, but then at the end, it gets the technology and also learns how the technology works, learns to build trust on the technology. And meanwhile, you are going one implementation by the other, and industry builds that trust. So I believe that this business model, so sure, we need policy support, but these new business models are also opening new frontiers. And that's what we need, right? Services rather than everyone taking the risk of buying something that they don't really know how it operates, right? So.
Yeah, absolutely. And there's something in the chat that sort of indicates that sort of fear around how do these things operate and so forth, and are there things we should be worried about, which is actually a pretty good pathway into the next question that I have. And I guess this is the more challenging question, right? So let's say we are successful in significantly increasing uptake of electrification of industrial heat processes and in lots of other areas of society, including vehicles and so forth. Should we worry about things like not having the supply chains in place to sustain this? Should we worry about the availability of electricity at an affordable price and so forth? And that's also a shout out to Bradley Anderson, who I think is psychic, because this is the second question that he sort of predicted immediately prior to it coming up, sort of just asking, given the speed of it, have we looked at whether or not the NEM can handle an increased load? And on top of that, I would also pose that supply chain question, the affordability question, just all of these kind of fears and concerns we may have about, you know, what would a real acceleration look like, and can we handle it? Are we ready for it?
I'll have a first go. So there are a lot of issues there. Of course, electrification raises, for an individual business or for the whole system, raises the salience of secure and affordable electricity supply. There's a lot of attention going into that at the system-wide level, but yes, it's going to be absolutely ever more central. The supply chain question is a really interesting one, both because a lot of energy equipment supply chains globally are challenged right now, that we are emerging out of the pandemic-induced supply chain challenges, but into a new set of challenges based around all kinds of major economies wanting to go much faster on a range of critical new energy and clean energy technologies. And the scale up involved to meet all of that demand for batteries, for heat pumps, for electric, the transmission lines, and much more. There's going to be a lot of challenges, even before you get to all of the friendshoring, reshoring, reduction in over-reliance on potentially insecure supply chain nodes that is going on. That said, a lot of the heat pump difficulties, I think, are most evident in trying to meet residential scale heat pump supplies globally. The supply chains are a little different, as I understand it anyway, for industrial heat pumps. But this is an issue. I think in terms of system impacts of electrification of industry, this is probably an easier problem to solve than it is for household electrification, because households are very peaky. And a lot of industrial use is 24/7, 365. Now, of course, achieving that level of reliability and always onness is a challenge of its own. But in terms of the stresses placed on the wider grid, industrial electrification may be much easier to digest than household heating, water heating, where the quality of the electrification, the concentration of it, the timing of use, the efficiency of the appliances makes the difference between adding a little bit to electricity distribution network system costs or a lot to handle a very high increase in peak demand through bad quality electrification.
So I've put a few numbers there for some modelling that we've done. It's for electrification, somewhere around about 250 petajoules of heating to be electrified, or likely to be electrified. And I'm going to put that at about 30 to 40 terawatt hours, which is roughly 50% of the NEM. So yes, that's not going to happen straight away, but this is not going to ramp up quickly. And the big energy user for that is within alumina. And they're located mainly in southwest WA, so that'll have its own unique issues there. In terms of doing this to make sure it's all done well, this is all about electrifying efficiently and smartly. And it's a very good opportunity to do efficiency when your new incoming technology, your heat pump, is 5 or 10 times the cost of your old technology. It just pays so much better to do energy efficiency first now, because you've got to make that investment, which is so much higher per kilowatt, say, of installed capacity. So energy efficiency and doing that efficiently has to be done first. And then I'll say smartly, and this is about really understanding about the supply and utilizing low cost electricity in the middle of the day, and designing your systems and allowing, using chemical and thermal batteries, that you can be able to turn them off for a couple of hours, maybe in the morning and in the afternoon, to handle those peak loads where where resident people are coming home and they are going to switch on that air conditioner almost no matter what, and getting ready for that sort of thing. So efficiently and then smartly thinking about these different tariffs that are going to be coming towards us.
Fantastic. Does anyone have any further comments about that one, or should we move on? Feeling like it's time to move on. There's a lot of good sort of questions in here, and I just draw the panelists' attention to a few people in the Q&A sort of asking, hey, do we know of any good case studies available online showing where industrial heat's been successfully electrified, and, you know, providing information on saved OPEX and emissions reduction and so forth. Yeah, something similar around examples of practical implementation of energy as a service model. So either feel free to say something about that now if something jumps to mind, or otherwise I would encourage panelists to drop any links or any advice about those things into those questions from both Candice and Atta. Moving on from this, actually one more, which I think might fit in this category a little bit, is we've got someone asking around, well, look, this is really complicated. How do we explain the complexities of electrification to boards and CFOs in such a way that they actually feel assured to release the capital to support this? So I guess this is a follow-on from the question that we've had around sort of these fears that we may have about doing this. Do you guys have any insights for sort of what's the pitch? What can we tell this person to go and tell the CFO?
I think Silvia said it well when talking about these business models and energy as a service, and building the ESCO, the energy service market here in Australia. It's very immature here, especially compared to other areas like in Italy. And so building that up and building that confidence there, that and taking that risk away by saying, look, here's your energy supply contract or heating supply contract, and we'll take on the risks around that. I think that's the business models is a great way to move things forward. If I just jump back and talk about references for a moment, there is certainly plenty building in Europe at high temperatures, up around 150, 160 degrees. Plenty of demonstration projects around there. There is certainly one right here. This is a heat pump at Montague Apples out there at Narra Warren. And that's a CO2 system providing cooling and heating. Fabulous results, getting really good performance and emission reduction out there. You've got a series of industrial heat pump solutions that have gone in around Australia over the last 12 months. I think there's now about 4 or 5 of them, with about 20 or 30 in the works, in the planning. So I think we'll see it ramp up pretty quickly, and maybe that'll give more confidence as these more local references come in and show, hey, this is what's possible, it's what can be done.
I've put a link in the chat to a Twitter thread of breweries using heat pumps. It's a fun little thread.
Fantastic. So for anyone who is looking for some case studies or some practical examples, that would be a good one. And I noticed someone in the chat just has noted for Melburnians, check out Three Ravens. Shout out to them. They won an award at our awards this year. So I'm glad that people are paying attention to that. Hugh has put forth a really fun question for the panel, which is, if the panel was developing a grant or funding scheme for industrial heat electrification, what would it look like? Guys, come on, let's solve all the world's problems and design a perfect scheme right now in the next 3 or 4 minutes.
Sometimes I feel like that's how some of the real schemes were designed.
Oh, spicy. Okay.
Hashtag not all schemes.
Hashtag not all schemes. All right. So in this hashtag this scheme, what sort of characteristics, I guess, would be, obviously we're not going to go specific, but what sort of characteristics would make for a good grant or funding scheme at the moment?
We just have to see to follow what was done in New Zealand for their GIDI program. It's working so well. So many projects are being funded and successfully decarbonising over there. And if you look at where the money is going, it's sort of 1/3 energy efficiency, 1/3 electrification with electrode boilers, 1/3 with heat pumps, and about 1/3, 4/3 is also because they're also doing energy efficiency as well. And so that program is going to deliver some amazing benefits over there, and we just have to emulate that. But it did start with a big mapping exercise, which A2EP is happy to be working with the federal government on that one now, of mapping out the major boilers around the country, and then saying, right, who should be using biomass, or who should be using biogas or electrode boiler or heat pump, and really trying to help them with that matchmaking of fuels and opportunities there. And so, yeah, look, we're a couple of years behind them, but I'd like to think we can catch up fast. But their model is working extremely well. Co-funding, I think they're doing most of their decarbonisation. They're estimating at about $10 per tonne of CO2, 10 to 17. So it's working well. We just got to do that. The technologies are here. We're just, none of this pie in the sky stuff. Stop with the trying to reinvent wheels and come up with the next big thing. The building blocks are there. We just got to get smart at implementing them.
Yeah, maybe if I had some grants to give away, I would definitely invest in demonstration projects, right? Something we saw how successful this was in Europe, and I think I'm talking about dry efficiency project, then led to new projects now that are ongoing. So these projects where you bring together academia, academic human power, you bring together industry, but industry stakeholders, from who produces the compressors, who produces the refrigerants, who makes the heat pumps, you bring all these human force together to implement concretely in an industrial plant an heat pump. This is really what makes electrification advance, because you build trust. And it doesn't matter if the heat pump is installed in a brewery and then the company who is thinking about installing an heat pump operates in the pharmaceutical sector. As soon as they see that there is the system works, this builds up trust. So, and bringing together really different types of stakeholders, right? Not only who produces heat pumps or who needs the heat pump, but everyone together to develop these technologies. Because yes, it's true, we do have these technologies ready in many cases, but sometimes the question of industry, for example, relates on, okay, I want to electrify my process, but my process is above 100 and they have this uncertainty. There are the capital costs. They want to see how it works, because let's remember that we need new workforce, new special engineers that are really experts in how heat pumps work, but also how to efficiently design an industrial process, right? That's also what we need, to redesign industrial processes. It's a huge novelty, and these projects can really make the difference. So if I had grants, I would put it into this type of projects.
And your points, Jarrod and Silvia, are dovetailing in a sense. You know, Jarrod, you're saying, you know, let's move away from pie in the sky stuff. Let's sort of get things moving. Silvia, you're saying we need things that work across multiple types of manufacturing, different types of industry, so that trust is built. Like, okay, this exact thing worked over in pharmaceuticals and it can work here over in food manufacturing. So it seems like your points are coming together quite nicely there, which is good. Is there anything else any of you would like to say on building the perfect scheme?
I would say two things. One is that any scheme to be effective needs to have a long enough lifetime that businesses are going to have the time to find out the program exists, work out their opportunities and apply for it before it's gone. We have had some very temporary policies, and we've had policies where the period was such that if you didn't already have a fully fledged project in the bottom drawer ready to pull out and submit, you are not going to be in the running. So we need things that last longer and have more of a lead up to them.
Yeah.
The other thing is, I would say we need at least two kinds of policy here. we do need policies that will support the deployment of the stuff that is ready to go now and is the cheapest option for reducing energy costs and emissions. We also, though, are going to need technologies that are expensive today and will only get cheaper by doing more of them, even while they're expensive. And policy has got to put its thumb on the scales to get those things deployed. And a design that's suitable for one is not going to do the other. Something like a white certificate scheme, we've got those in New South Wales and Victoria and South Australia. They are good at promoting the next cheapest opportunity to reduce energy demand at a mass level. They have been absolutely rubbish at deploying more advanced stuff, more comprehensive upgrades and novel technologies, because that's not what they've been designed to do. So we just need to be clear about what our objectives are and ensure that we've got appropriate policy tools for all of those objectives, not one size fits all.
Absolutely. And these white certificate schemes, expansion of what can be used for a deemed, so the measurement verification, not so much needed, and it just comes automatically, so that somebody who may be looking to put a new site in or expanding their production, they can still get the benefit of those sorts of technologies. And then when it comes to that retrofitting, this, as Tennant pointed out, very few projects for energy efficiency and heat pumps and things. I don't think virtually any have been registered for the measurement and verification methods for them and for ACCUs. There needs to be a lot more confidence how that can work and who's doing what, and ensure that goes into the business case, not just we might get 20% of the capex back through white certificates, but we might not. You can't have that. You need that 20 or 30% that really tips it over from those what we often see payback periods somewhere around about 6 years, and just tipping it over to that 3-year period where it gets a little bit more oomph and board recognition and notice and capital allocation.
And that's a common theme, I think, in industry. These flash in the pan type programs are just not really working for industry, regardless of which industry it is. I don't know that I've seen any that have been wildly successful for exactly the reasons that you've outlined. Industry needs time to identify the opportunity and move with it. Jarrod, this is a real quick one for you. Can you just confirm for Erin which program in New Zealand you were referring to?
They call it the GIDI. I won't do my New Zealand accent, but it's GIDI, Government Investment for Decarbonising Industry. Okay. And if you did a like-for-like dollar basis, it'd be about $4 billion in Australia. And I think they've got 700 million for industry. They've just recently announced 100 million for commercial buildings as well. Serious money. But they've got the emissions trading scheme, and they've got a way to fund it. We don't have that, so it's not so easy for us to do that. But that's been a great scheme, and it's getting great results. Lots of learnings, lots of local content. A couple of years' time, when you hear about properly decarbonised dairy and meat coming out of New Zealand, you think, "Oh, that's really might start taking a bit of market share away from Australian exports." Then we might accelerate a bit there.
Plus, it's nice to have examples that are more local. It's fantastic to learn from Europe, the US, everywhere else, but it is also nice to see, a region so close to us and similar environment. We co-created the Pavlova. We share Crowded House. So we have a lot of similarities with New Zealand, so it's nice. Now, I'm cognizant of the fact that it is 4:55 and people do want to get out. But there is one more question here that I'd love to try and squeeze out, coming back to the earlier, more technical side of the discussion. And it's from David, who's asking, how important or not important is looking at optimizing existing plant and equipment to right size demand before making capital investments? And are there guidelines or rules of thumb for savings achieved?
Oh, thanks, David. I thought you'd never ask. So we've done 30 or 40 feasibility studies and overlooked another 20 or 30 or so. So we've seen this many times. And that right sizing usually comes from data and understanding your thermal profile. and understanding of the savings you can get when you're moving from a steam system to a heat pump type system, which is typically around about 30 or 40%. If you look at the entire steam system, just the boiler, 20%, another 20% from the steam system, the losses there. So I mentioned before, maybe 10x is the difference between a gas boiler and a heat pump. You can for sure get that down to less than 5x when you do get the right sizing and you don't think like for like. So if you've got that 1 megawatt boiler, you know, really your aim should be to be getting in a 500 kilowatt heat pump or less by using, getting the data, understanding your profiles, doing energy efficiency first, and employing things like thermal storage. That's just an absolute game changer. And when you do that, you're really looking at those payback periods of less than 3 years. So absolute game changer there.
Fantastic. Well, with our last minute, there was an early question. We don't have time to get to all of it, but I think it's an interesting point to end on, which would be how do you see Australia's maturity compared to the EU on this front? So it's a yardstick, I guess, for how we're doing with a region that's very interested in this.
For research and development, you'd give us 1 or 2 out of 10 versus if you said 10 out of 10 for Europe. As what Silvia mentioned before, for dry efficiency, they've just miles ahead of us there. For adoption and things, I haven't seen updated data. There hasn't been much. There was a nice website which was updating heat pump installations in Europe for a while, but it's just getting a little bit dated now. They did a fair few through the 2010 to 2020, but it's hard to see where things are at now. There's lots of publications around residential, what's happening there, and the millions of heat pumps, but it's a bit hard. I haven't seen much on industrial.
I am very tempted to mention my favorite public policy concept, but I will just say instead that Europe is very aggressively seeking to reduce economy-wide emissions, and they are pushing hard through price instruments, regulations, and otherwise on industrial gas use for security reasons, national security reasons, as much as anything else. They are pushing electrification very hard. They are also pushing everything else. They are in the process of adopting a target to use 20 megatons of hydrogen a year, green hydrogen a year by 2030, which, that's a big number. That might not even be a sensible number, but it's a very big one. And biogas and just good old-fashioned energy efficiency too. So they are grappling with the reality of everything needed to be done to achieve very deep emissions targets. Our emissions targets are getting pretty deep too, so we may be catching up to them. And if we don't, we will be having some problems with our own goals. Fantastic.
So with that, and in the interest of time, I'll just finish with a public apology to everyone whose question I didn't get to. So that's Ross, that's anonymous attendee, Rajesh, Ada, another anonymous, Brian, and Tom. I'm very sorry that we didn't get to your questions, but thank you very much to the panel for your time today. Thanks to Jarrod for putting CBAM in the chat to make Tennant happy. It's been a really interesting discussion, really interesting topic. I'm sure it's not going to be the last time that we're all here talking about it. Jarrod's put his email address in the chat, so feel free to forward any questions there if you still have them. Everyone else is on LinkedIn. Tennant's pretty active on Twitter, so you can get a hold of us if you'd like to follow up on anything that we've been talking about today. Thank you very much for your time and for coming along.